So, we are here to tell you about a tale, and we're going to start with a small introduction. Rutger, tell us about it, the best of times you had.
Oh man, it was the best of times. 1 year and 6 months ago I graduated on a topic that involved Lewis. Hence, who knows Lewis? He's a fun guy. Language understanding processing of Microsoft. I love him. It involved Microsoft Bot Framework as well. It really was the best of times because I got to work with exciting new technologies. And yeah, it were good times, no problem.
Good. So let me tell you about my times. For me, it was actually the worst of times. I was doing on-premises at a customer, and I loved the customer, but what we were doing was boring. We were building old legacy code. So we were just doing things that we've already known for years. And then all of a sudden the customer was like, yeah, did you hear about the stuff Microsoft is doing around AI? And I was like, yeah, of course, I want to do AI. And this customer was like, yeah, but we've got a problem. We are still on-prem, and we're not allowed to go to the cloud. So please fix that for us. Oh, and by the way, I got a demo that I've got from someone at Microsoft, and it was about automatically tagging content. It was about extracting data from content. Can you build that for me on premises? And I was like, that sounds like a challenge. So I involved Rutger, and we had a look at what we could do, and that's what we want to talk about today. So what the customer actually had seen was the GFK files. How many of you have seen that demo? Okay, a few of you, not everyone. Basically, Microsoft released a demo where they got a large data set. It were all documents, PDF files, it were scanned letters, and what they did with those documents is they did entity extraction. So they got that content, they extracted relevant information out of that content, and they build a web interface. So you can browse through that web interface, you can find files, they show you a nice graph where they show relationship between the different types of content. And as you can see, they do like highlighting, so if you search for Oswald, you actually will find everywhere that word is used. Really powerful. The thing is they build it with Azure. So you can go there, it's the URL is in the slides, I will share the slides with you. You can go there yourself, you can see what it is. It's a really nice demo, but it is all in Azure. So what we are going to talk about today is using AI to classify data in SharePoint, especially SharePoint on premises. So it's not going to be SharePoint Online. There is a bunch load of announcements that have been done at the Ignite. I'm going to show you a little bit about that, but it's mainly about SharePoint on premises. So what I announced at Ignite was Project Cortex. And Project Cortex is basically the next step, according to Microsoft, when we talk about knowledge. Any data that you would put into your SharePoint environment will be shifted through by using AI, using machine learning, using form processing, using text recognition, and get information out of that content. So that sounds really, really powerful, because what that will bring you is it will bring you something called knowledge entities. So if you upload a document, it will sift through that data, and it will figure out what the document is all about. That sounds promising. What you then can do is you can find that knowledge and do things with specific types of pages, or you can do specific roll-ups saying this is related content to what you are looking for. So I've got two screenshots because it's not live yet. What you will see here is you'll see a page. On that page there was just text content, and the system recognizes that there is content on here on something called core. And that core is actually something that has been identified as knowledge. So if you hover over that entity, it will actually show you it's about construction operations reliability, and it will show you related content for that topic. It will show you people who've been working on that content. So that's actually pretty powerful. It's a nice way of enriching data that you already have in your environment. Now, if you would click through, you will actually come to a topic page where you can get an overview, get some additional content. You will see people working on it. You can see all the resources related to this topic. You can find things like related sites or related topics. You can use Yammer to do questions and answers. And the whole thing about this is that it is AI but it's also allowing you for end users to modify this page. So all the content, all the related stuff is actually found through search and through machine learning, but you as an end user, if you do have permissions, you can modify this page and enrich it yourself. So this is a really powerful way for organizations to work with. Now, one of the things that's behind this is Azure Form Recognizer. The logic that is in Azure Form Recognizer allows you to put in text and get the data from your document back. So if you have a PDF or you have an image, you can actually upload that file and it will tell you specific numbers, specific labels, and you can use logic like this to extract data from your documents. And this was stuff that our customer has seen, and they were like, yeah, we need something like that, but it has to be on-premise. So what was our case? We had a customer. That customer said, I have a really, really large data set. It was roughly 3 terabytes of data, and in that data set, we have mainly Office and PDF files, and it's all in structures. It's a file share. We dumped everything into a single folder. Actually, there were 2 folders, but that's what we have. And I think some of you will recognize that most customers still have legacy systems like that. And it was not searchable. It wasn't a file share, so you would have the Windows search experience, but there was no full text search. So finding content in that data set was pretty hard. Now, there was no metadata. If you know SharePoint, you know you can use metadata in SharePoint, but it's a file share, so no metadata there. Well, there is some metadata, like last modified date, the author of the document was available, but that was basically it. Some of the files were actually scans of typewriter data, really old data. Some of the scans were just scans from printed documents, and there were some Word files that were a bit more recent than the other files. Now, the main reason they wouldn't want it in the cloud was legal. There was no way that we could convince legal that it made sense to move to the cloud. And Rutger, you've tried, right?
Oh, I tried hard. They just wouldn't. I understand, they wouldn't.
How many sessions did we have?
Lots.
I think we did like 5 different sessions with legal, just trying to figure out why are we not allowed to move to the cloud.
No chance.
We ended up with one compromise. We were allowed to send some of the metadata to the cloud. So they allowed us to send some data to the cloud as long as the main document wasn't moved to the cloud, period. So what we did is we had a look at those files, and it was unstructured data. So it was a bunch of files. And we started out with just clicking through the data to get a feel. What documents did we have? What PDF files did we have? There were some TIFF files in there as well. So what percentage of data are we working with? And we encountered that most of the data actually did things like a title page or a footer or a header. So there were some chunks of data that we could work with to extract some more detailed information about a document. Now, you can imagine that if you have a PDF file of over 50 pages, that 9 out of 10 times there was actually a title page, or there was actually an abstract page that explains the management summary, things like that. So if you look at the files, you will see that there were different types of files, different types of data, but almost all had at least a title page, a header, or a footer. So what we did is we came up with an ID, and with that ID, we tried to design a system where we could extract those titles, where we could extract those title pages, and use that into our AI model. And we checked we were allowed to send the title page to the cloud. So what we did is we had a look at a system they already had. They had SharePoint. And if you know SharePoint, you know you can use SharePoint to do full text search. If you put a PDF into the SharePoint search index, it will actually find that for you, and you can use the full text search experience, find content based on that. Now, the cool thing about the SharePoint search index is that it's actually extensible. The SharePoint search experience allows you as a developer to hijack the search and the crawl process. So you can inject your own logic. And that's what we did. We did a schema, and as you can see, we had our network share top left. That network share, we put it to a site collection. We just loaded all the data into that search index. And if you look at how SharePoint works, what it actually does is it starts crawling. That's just picking up files like any search index would do. And then it would go to something called content processing. And the cool thing about content processing is that you can inject that with your own logics. So if you would drill down what's happening in content processing, it will do document parsing, trying to figure out, can I actually open the document, can I get information out of the document, and in that document processing, or the next step, is actually something called content enrichment. And content enrichment is a service that you can build yourself. It allows you to call an API, a web service, any web service that you can come up with. So what we did is we actually built such a web service, and in that web service, we did smart things like metadata extraction. We figured out what is actually the page that contains the data that we're looking for. We then got that data and we cleansed it a bit because maybe there were checks like high confidential data. So if the title page contains the stamp high confidential data, we are not sending it to the cloud. If it does not contain that stamp, we are allowed to send it to the cloud. And then after the data cleansing, what we did is we injected it into Lewis. And that's where I really needed Rutger to explain to me how to work with Lewis. So Rutger, tell us a little bit about what we did.
Yeah, I guess you're all waiting. When does the AI kicks in? Right now. So we had this cleansed file, you know, like just the metadata, at least what we thought would be metadata on the page. And now we needed to extract this key values, really. And because I did my graduation project with Lewis, I thought like, okay, Lewis is a way to understand context and to pick entities out of it. So I thought we can maybe abuse Lewis a little bit and have it think like we're making intentions, while the only intent we have is extract metadata. So what we did is we sent the page over to Lewis, and Lewis just process it like a natural language processor and give us back the entities. But to really understand how Lewis works, what does it do? Lewis mainly consists out of three big parts. Those are intents, those are utterances, and entities. So the utterance is, what does a user say? I mean, Lewis is a natural language processor. It's mainly used for chatbots. So what does a user say? Let's say I want to book a flight, right? That's something you could say to an airport company when you book a flight, like at the chatbot. So I say, let me book a flight for tomorrow at 3 p.m., right? Then the intent is book a flight, right? Our intent was extract metadata. And then the entity would be tomorrow at 3 p.m., because that's the parameter we're putting in that context. So we tricked Lewis in thinking we were actually processing natural language. What we actually did is extract entities, which was exactly what we're trying to do. So we had this page, the splitted metadata page. We sent it over to Lewis. Of course, we trained the model. We had some sample utterances, like how could the data look like. We trained the model. We put in the entities. We have some pre-built entities. You can create your machine-learned entities in Lewis. And then we would send these 10,000, I think, of documents, or a lot, into Lewis and see if we got any entities back. And actually, I think within 3 days, we really had a good model. The model was able to understand 80% or get back 80 to 95% of all entities that we put in as input.
So just to make sure, I'm not a data scientist. I love the AI part, but I'm not a data scientist. And even I could figure out how to do it once I got a hang of how Lewis works. It's just calling an API, injecting the data that you have, and training the model. And there is this nice UI that you can use to actually train it. So
you don't have to be a developer to actually use Lewis. I mean, sure, we had some code in, extracting the metadata page and cleansing it and such, but I think anyone can use Lewis. It's really intuitive. So that's what we did, and as I said, within 3 days, we had a real good result. And we got back like a lot of entities, so we could then enrich it into the document in SharePoint as metadata.
So we did also have a look at Azure Text Search. Tell us a little bit on why we chose for Lewis. So what was the reason that we thought made sense to use Lewis instead of text search, text analytics?
Well, with text analytics, you can get some, you analyze text, of course, but with Lewis, you can really create your own entities. So, for example, a published date, it's a pre-built domain, it's a date. But sometimes with a first or last name, it differs per document. So you could train your own model. With text analytics, you really couldn't that much at the time. So Lewis was able to let us create our own model within the Lewis domain. So that's why we use Lewis. We did use text analytics to determine the language, because per Lewis app, there is one language. So we had documents in French, Dutch, English. You have to create an own model for that, for each language. So we first actually called the text analytics. We asked, all right, what language is this document? And then we would go or point to the Lewis domain for that language, of course.
That makes sense, makes sense. Now, how many of you have seen SharePoint? Okay, so that's good, that helps. Because this was done at a customer, and we did check, can we tell customers, or can we tell anyone about what we did here? And they were like, yeah, no, you're not allowed. So I did manage to sneak out a screenshot, but it's kind of redacted. So our legal department allowed me to show things like this. Basically what we did is we scanned that file share. Everything that is black is SharePoint results. But what is important is it's a research department, right? What we could do, because we have Lewis, we could extract certain types of numbers, certain types of names, certain types of information that we could then use to do filters or do refiners. So you can imagine if you have like 3 terabytes of data that it's hard to find something. As you can see, we put out the ISBN number, which is like a identifying number. So if in any of these documents you refer to another document based on that number, you can actually say, okay, give me all the studies that refer this number. And obviously in this screenshot, it's just the ISBN. I think the next screenshot here, you can see that we did a debug template, but what you actually see is that we get a different set of properties. So we get some raw data. We scan data for authors, so we get back authors regardless of whether they worked on the document. If they are in the title page, we can actually extract that because Lewis does understand how a name would look. And what you can then do is you can get the data and start processing it further, because that actually is like the next step. We didn't do that in this project, but if you think about it, it is really, really interesting. So we scored between 80 and 95% of auto-tagging. This is pretty good as far as I'm concerned. I'm not sure, maybe you will tell me that we can achieve even more, like 99% would be awesome. But, well, we could do better by tweaking the model. Second thing, if you get back names of people or specific numbers, you can actually go back to different systems that are already running internally. I mean, you will have an Active Directory with all your users. So if you have a display name of a user, you can actually try and reach out to that Active Directory, find that actual username, and link the document back to him. If you have a project number, you can actually go to ERP or a line of business application where you figure out who was the project manager for this project. And then all of a sudden, all those documents get so much more data than just what's in the file already. And finally, now we did most of the things with Lewis. And right after we released this project, they actually told us that we could download or run Lewis models locally. And obviously, that would have made things so much more easy. Train your data in the cloud, get your container locally, run everything locally. That way you only have to create a set of training data. That training data is something you will put in the cloud, but everything else could run locally in a Docker container. We did play around with it, right?
Yeah,
it did work.
It worked. Very good.
So, are there questions on that?
Yeah, you're saying you're training Lewis for entity recognition.
Yeah.
But the training takes time. You said that you did it in 3 days.
Yeah.
Well, how did you train? So you have 10,000 documents and you distribute 1,000 to your subject matter experts, so they are highlighting all the words.
No, what we did is we got a set of documents. We got roughly 1,000 documents to train with. Those 1,000 documents all contained a title page within the first 5 pages. So we wrote a small application that stripped out all except the first 5 pages of all documents. That's what we put in the cloud for our training model. Then it takes, I don't know, maybe 1 or 2 days to actually configure and play around with a model. Obviously, you can train the model while you are asleep, so you don't have to wait for it to finish while you are working. That's why we got it in roughly 3 days, a first version. Make sense? Then finally, obviously, the 3 terabyte takes longer to process because the SharePoint index takes, it took almost 7 days to index everything, and then it takes another, I don't know, 5-6 days to call Lewis for each document and get the data out there.
So from the beginning to end, how long it took for this project?
25 days. So a little over a working month. And it was the 2 of us. So no, well, there were some technical guys involved for the SharePoint part to set up the servers and the demo environment, but that's it. Other questions? If there are no more questions, if you want to reach out, we both have a blog, we have Twitter, you will find email addresses on our blog, and the slides will be shared.
Yes.
Right on time.
Perfect.